exactly I did in Bioimagine as a concept. So Bioimagine as a company, the concept was that we could see radiology industry, and then all the radiologists are using or looking at the films, which are no more the films as a film, but it's all digital media. Whereas if you look at pathologists, maybe the similar entity in the next room of the hospital, the pathologist is still using the microscope. Now, if you look at microscope is an optical device which is 150-year-old invention. So, on one side, when everything is going digital, when the information technology is crossing the roads with that healthcare aspect of radiology, pathology was still optical. In fact, there are a few downside of it. Number one is that when you are trying to look through microscope and you are trying to look at any of the cancerous tissues under the microscope, you are looking through eyepieces and you are looking at a glass slide, and he is writing something on the paper. So what he or she sees and what he writes, there is no transparency in that. So it's like a black box model. That creates two problems. Number one, how accurate that diagnosis is, because that's going to impact on the patient straight away. At the same point of time, if the diagnosis is wrong, that impacts on the physician or the pathologist himself or herself, because the patient may sue that pathologist. So for both of the entities, pathologist as well as the patient, having a complete transparent model which has an objectivity involved was the need of the time. Nobody had done that till then, because they were, the big companies like the Siemens and the GEs and the Philips of the world, they will never be the early starters. They will never start with a concept. They will just watch out, what's happening around. They will find out, still there are some startups which will start some new ideas, and then once that startup goes to some maturity, and then these big guys will come and have them in. That's how the industry grows. But then from that perspective, pathology was in a very nascent stage. And that's exactly the area that we felt that probably is the right place to go. And then that's where we built a product which can actually, by using the imaging techniques, because imaging is something, was the differentiation that we could bring to the table in terms of the technological differentiation. We built some of the pattern matching techniques which helps to identify the patterns in terms of the cancerous tissues. So the vertical for us was a cancer, and the solution, technological solution, was the pattern matching solution. So instead of using this microscope as an optical device, you can have a camera on the top of it, you can take an image, and then you can make it more objective. So the way it was useful for the diagnostics, it was also very useful for the research space, because a researcher, when he or she is trying to discover or develop a drug, then they had to actually apply that drug on the tissue lines. So they create something called a microarray. So on one glass slide that all of you must have seen in the pathology labs, there are 100 such small tissue cores are printed, and then they have to actually go under microscope for each core and write down the scope. Now, classic case happens is that when they are moving left, right, left, because they are looking through microscope at 20x magnification, and if they get a phone call, once they come back, they have no clue whether they came from the left side or the right side or what to do, and then they will again start if they don't remember. So this whole process was taking around 6 months. And that impacts eventually the drug discovery and development process, because every new drug that comes to the market is a process of around 6 to 7 years, and they spend around $2 billion in doing that. Every big company like any pharmaceutical company, they can't afford not to come up with a new drug. They have to keep 6 or 7 drugs coming at the same point of time. So our approach was simple, that we build a solution which can actually help in the diagnostic space for pathologists and patients, and in the research space help expedite the drug discovery and development by reducing X amount of time that eventually impacts on their total development cost, resulting into the return of investments.
So you have both hardware and software with you?
So initially we started with only software, because then we were working with the likes of many microscopy companies started developing hardware as a logical transition for them from microscope to this digital device. So we worked with them as their software partners, and then we actually build our solutions on the top of it. And then in 2006, with our venture funding coming on board, we developed our own hardware.
So who are your main customers? Are they government or the medical institutes, hospitals, or where you position your product?
Yeah, so mainly the pathology laboratories. So as a statistics, there are around 35,000 certified pathologists in United States alone. There are around 150,000 molecular biologists in the research space. So the market size is significant. So our business segment is essentially the labs, the clinics, pharmaceutical biotech companies, and as well as hospitals. And this is where our solution was deployed. And there is also something a need called as a second opinion, because many of the times doctor is not able to make a decision. So he would like to have somebody's peer review for that matter. So again, as a statistics, around 25,000 flights are sent over FedEx for a second opinion every day. So this solution also saved that cost, because then you are not physically sending the slide, now you are sending an image through which it can be done. The downside of this was it's all a regulated environment. So all FDA scanners come on this, and that's where we also had to go through FDA procedures to get clearances. And I'm happy to actually tell you that in the solution we started in 2005, they completed 7 years. And in 7 years, so for one of the big laboratory organization called the LabCorp, so in 7 years, they actually completed 10 million cancer cases. And that essentially, so they have 150 pathologies as a group. So now they're all digital. So, it's good to see that, right? I mean, IIT's dream, then your aspiration of doing something, you want to do something, you are doing something, and then whatever you have done is being utilized and used by somebody. So I think that helps a lot. And what you are developing is also something which is being used for betterment of mankind. Because our solutions are mainly for the breast cancers. And as a part of the screening procedures, every female above 35 should be going through breast cancer screenings for the possibility of any of the breast cancer condition in the future. The subjective technology creates a problem, because if the female goes there and if the doctor makes any problem, then after some time when she comes back, she gets into the cancer at such a stage that it's just difficult to cure. And that's where this objective analysis made a big difference. I also have 11 international patents on that, so I think that made a big difference in terms of keeping ourselves away from the likes of GEs and Siemens of the world.
That is fantastic. How that is used in India? Is it used in India in various places?
Not really. So in India, what's happening is that number one is that the rate at which the patients are coming to the doctor is so high.
High.
Yeah, because in India, if you look at the patient density, the doctor is literally handling many patients at the same point of time, not really one at a time. Number two, the patients who are sitting in the rural areas, they even do not have the right knowledge available in terms of the physician's capabilities. And number three, the cost of the equipments. So from all this perspective, just like a few months back, Government of India's Department of Biotechnology, and they have something called as the Department of Science and Industrial Research. So they have signed up us, Opera Systems, as their partner for building the affordable devices. So one of the devices that we are trying to build is in this space of cancer diagnostics, mainly focusing on the rural areas, where how can we actually get them and help from the good physicians sitting in, say, Bridge-Candy Hospital or even Ruby Hospital for that matter. So that's an initiative started, but to answer your question, probably at this level of cancer diagnostics, there are no such automation kind of the tools that are available today, which can really help the patient not to get a repetitive or an objective diagnosis, but at the same point of time at a lower cost, because that's one of the important things. But because otherwise, then it will only address the upper strata. That's not going to help country as a country. That's not a real representation of the country India.
So you have a billion-dollar opportunity there. If you create some kind of device which will work in this Indian context,
yeah,
you have a very large market available for this kind of innovation.
Yeah, that's right. I mean, it's a good market. It's again a paradigm shift. So it's not something that is a killer product, because it's also a question of educating the physicians to rely upon this. Because because they feel very comfortable in, like, I look at it, I sign it off, it's out. Because the number of cases that they can handle by virtue of they doing only manual analysis versus automated analysis, there has to be a motivation for them to go for the automated analysis. And that motivation could be either by way of extra remuneration that they get, or it has to be a government mandate. Because they're the only two things where a human being can change himself or herself. In India, there is neither a government mandate, nor there is a chance of getting more remuneration, because doctors are really handling the rate of the patients coming to their desk at such a fast pace compared to probably anywhere in the world, because the quality of the life is very relative term.
India story, why you came to India?
Because I'm Bharatiya, so apart from that. So I always wanted to be here, and that's where, because geography was not really my aspiration at any point of time. So as I said, maybe earlier I would have started with just look offer as well. So my aspiration was only like entrepreneurship. I wanted to create something. I wanted to kind of grow in that space. It just happened to be in US because Tata Consultancy sent me US, so I went there.